I've spent decades in planetary science, and I can tell you, what we found beyond Neptune's orbit shattered everything we thought we knew. These aren't just frozen rocks drifting in darkness, they're worlds that refuse to play by the rules. Picture this: while textbooks were still showing Pluto as a lifeless ice ball, this distant world was hiding colossal ice volcanoes and an atmosphere that literally breathes, swelling and shrinking like living lungs. And then there's Arrokoth, this bizarre reddish snowman tumbling through space, holding secrets about how planets were born. What mysteries pulse beneath Pluto's frozen shell? How did cosmic forces twist Arrokoth into its strange shape? Could living organisms actually survive in Pluto's hidden ocean? These questions are pulling us to the solar system's edge. When New Horizons screamed past Pluto in July 2015, it destroyed every assumption we'd made about this distant world. We expected a corpse, a geologically dead frozen sphere. Instead, we found a young, dynamic landscape that had no business existing. The most jaw-dropping discovery? A network of massive cryovolcanoes, ice volcanoes unlike anything we'd ever seen. By March 2022, scientists digging deeper into the data found these giants in Pluto's southwestern region, right at the edge of that famous heart-shaped feature. Right Mons towers 4,800 meters high and stretches 145 kilometers across, roughly the volume of Hawaii's Mauna Loa. Nearby looms another colossus, Picard Mons. But here's the twist. These aren't fire-breathing mountains. Instead of molten rock, they vomit a grotesque slurry of water ice, methane, and volatile chemicals that ooze outward like half-frozen toothpaste. What's truly staggering is how young these cryovolcanoes appear. The surrounding terrain shows virtually no impact craters, meaning these monsters formed recently, geologically speaking. We're talking possibly just a few 100 million years, maybe less, a cosmic eye blink. Some scientists believe they might still be active right now, slowly erupting as frozen slush seeps from the planet's guts. This recent activity shouldn't exist. Pluto's only 2/3 the width of our moon, and sits so far from the sun that its internal heat should have died billions of years ago. Yet here stand these enormous ice volcanoes, proof that something is still generating energy deep inside. This forces us to completely rethink how dwarf planets work and raises a haunting question: what's keeping Pluto's interior warm? Some researchers point to radioactive decay in the rocky core, slowly releasing heat like dying embers. Others suggest antifreeze compounds deep within, substances like ammonia that keep water liquid even at brutal temperatures. Whatever the source, these ice volcanoes stand as frozen monuments to a world that refuses to die. New Horizons also captured something else: massive cracks spiderwebbing across Pluto's surface. These tectonic scars indicate violent internal changes. Pluto's icy crust has been stretched and ripped apart by forces surging from below. Scientists read these fractures as evidence of a subsurface ocean gradually freezing. Yes, Pluto likely harbors liquid water hidden tens or hundreds of kilometers beneath its shell. When water freezes, it expands, like a bottle exploding in your freezer. A slowly freezing underground ocean would push outward, cracking the surface. The images confirm this. Pluto's crust has been stretched and fractured over billions of years. But here's what's strange. There's no evidence the ocean has completely frozen, which would create telltale compression signs, sections of crust collapsing inward like a deflating balloon. New Horizons found no such compression. According to mission principal investigator Dr. Alan Stern, this absence suggests liquid water still sloshes beneath Pluto's crust today, but how? Surface temperatures plunge to minus 230 degrees Celsius out there. The answer lies in insulation and chemistry. Pluto's core retained heat from its violent formation, and recent research reveals something remarkable. At the base of the icy shell sits a layer of gas hydrates, essentially ice laced with methane. This acts like a thermal blanket. These methane-rich ices have incredibly low thermal conductivity, trapping heat and preventing the ocean from freezing solid. Add ammonia acting as antifreeze, and you've got conditions for liquid water to persist for eons. All evidence points to Pluto being an ocean world, joining Europa, Enceladus, and other icy moons in this exclusive club. But there's a crucial difference. Pluto maintains its ocean without a nearby gas giant pumping tidal heat into it. A 2020 study even suggested Pluto formed hot. Intense impacts during birth generated enough energy to melt the interior immediately, creating an ocean from day one. If true, that ocean has existed for over 4 billion years. This remote dwarf world is far more dynamic and potentially habitable than anyone imagined. And just above its surface stretches another surprise, an atmosphere that proved to be one of New Horizons' most stunning discoveries, captured as a blue halo backlit during Pluto's sunrise. For decades, Pluto's atmosphere had been inflating. When the dwarf planet swung closest to the Sun in 1989, frozen gases warmed and sublimated, pumping up atmospheric pressure. Between 1988 and 2016, observations showed pressure roughly tripled as nitrogen vaporized into the sky. But now Pluto's retreating from the Sun, and everything's reversing. In 2019, astronomers watching Pluto pass in front of a distant star got a shocking result. Atmospheric pressure had dropped over 20% since 2016. Another observation in 2018 confirmed it. The atmosphere is collapsing. Nitrogen is literally freezing out of the air and falling as frost. If current models hold, this marks the beginning of total atmospheric collapse. Scientists predict that by 2030, Pluto's atmosphere may vanish almost completely, transformed into icy deposits carpeting the surface. During the long polar winter, especially after 2030 when the northern hemisphere plunges into total darkness, temperatures will drop so savagely that remaining gases will freeze out in thick layers of nitrogen and methane ice. For decades, Pluto may become an airless frozen ball, its skies empty except for wisps of vapor near sunlit patches. But this isn't permanent death, it's a cycle. Centuries from now, when the South Pole tilts back toward the Sun, the atmosphere will resurrect as ice sublimates again. Right now, though, we're witnessing something rare, a planetary atmosphere collapsing in real time. As pressure drops, those beautiful blue haze layers New Horizons photographed will vanish. Pluto's overall brightness may actually increase as fresh, reflective ice blankets more of its surface. What makes this even stranger, in 2015, while flying over Pluto's equator, New Horizons spotted something absolutely ridiculous: dunes. Actual dunes, like wind-carved sand dunes on Earth. They stretch along the boundary between Pluto's vast ice plain and surrounding mountains. A 2018 study led by Dr. Matt Telfer confirmed it. These ridge-like structures extend 74 kilometers along the western edge of Sputnik Planitia, that massive heart-shaped plain of nitrogen ice, right where it meets the 3-kilometer-high water ice mountains called Aladrisi Montes. They form parallel ridges that look exactly like wind-created sand dunes, except the sand is frozen methane grains. But how can dunes form in such a pathetic atmosphere? Atmospheric pressure on Pluto is only about 1 Pascal, roughly 100,000 times less than Earth. Conventional wisdom says such thin air can't possibly lift or move particles, yet somehow Pluto found a way. During Pluto's day, solid nitrogen on Sputnik Planitia can sublimate directly into gas, releasing energy. When this nitrogen explosively expands and rises, it briefly picks up tiny particles and lofts them into the air. Dr. Telfer showed that if methane ice crystals just a few hundred microns wide get lifted by this sublimation, then Pluto's feeble winds, blowing around 35 kilometers per hour, are just strong enough to transport them and pile them into dunes. These wind-blown grains likely come from neighboring mountains, where methane ice accumulates. And since Sputnik Planitia's surface is geologically young, constantly resurfaced by nitrogen glaciers, the dunes themselves must be recent, probably formed less than 500,000 years ago. Pluto's dunes prove that even a whisper-thin atmosphere can sculpt landscapes. Mars has carbon dioxide dunes despite its thin air. Saturn's moon Titan is covered with hydrocarbon sand dunes. Now Pluto joins this club, demonstrating that planetary winds can shape worlds even under extreme cold and crushing isolation in the Kuiper Belt. After leaving Pluto, New Horizons rocketed toward an even more distant target, Object 486958, Arrokoth. On January 1st, 2019, the spacecraft screamed past this tiny world at just 3,500 kilometers distance, capturing pristine images. Looking like a cosmic snowman, Arrokoth consists of two lumpy lobes stuck together, measuring about 35 kilometers end to end, the frozen result of two bodies gently merging. The images revealed a remarkably smooth surface, uniform reddish color, and almost no craters. Arrokoth appears to be the oldest, most pristine object any spacecraft has ever visited, essentially a time capsule from the solar system's birth. Detailed analysis revealed something extraordinary on the larger lobe, nicknamed Wenyu. About a dozen wide bumps, each roughly 5 kilometers across. These bumps are eerily similar in shape, size, color, and reflectivity. New Horizons researcher Will Grundy describes it as looking like a raspberry made of identical segments. The smaller lobe, Weo, shows several similar features. The body is so perfectly preserved that we can directly see its building blocks, the original pieces that assembled it. These mosaic components prove Arrokoth formed through an incredibly gentle process. These aren't shattered fragments from violent collisions. They're siblings that grew side by side and gradually embraced. Everything about Arrokoth supports this. Its shape, composition, structure. The two lobes connect at a single contact point, and their axes and equators align perfectly. Both once orbited each other as companions and slowly spiraled together. The lobes themselves are flattened like pancakes, possibly the result of slow merger within a rotating disk. The surface composition is strikingly uniform across both lobes, indicating the material came from the same localized patch of the primordial solar nebula. If Arrokoth formed through traditional violent accretion, random collisions gathering debris from different regions, we'd see much more variety. Instead, all evidence points to a different birth story, the cloud collapse model. In this scenario, a dense cluster of particles in the infant solar system collapsed under its own gravity directly into a planetesimal, skipping the violent collision phase entirely. Study co-author Dr. William McKinnon explains that Arrokoth's components formed nearby, moving at glacial speeds, orbiting each other in an intricate gravitational dance before finally touching and freezing together. That faint reddish tint isn't just aesthetics, it tells a chemical story. New Horizons spectral measurements showed Arrokoth's surface covered with methanol ice and complex organic molecules, probably tholins. Surprisingly, no water ice showed up in the readings, which is bizarre since water ice appears on most outer solar system objects. Even tiny comets and Kuiper Belt bodies usually display its signature. The absence of water suggests it's either buried beneath organics, or the conditions during formation resulted in extremely low water content. Arrokoth belongs to the ultra-red object class. Its spectrum blazes red due to abundant surface organics. This reddish material is rich in tholins, complex macromolecules that form when cosmic radiation and ultraviolet light bombard simpler compounds like methane, ammonia, and nitrogen. Tholins aren't alive, but they're prebiotic, chemical building blocks that, under the right conditions, could spawn amino acids and other components of life. Methanol offers another clue, forming through irradiation of water and carbon monoxide or other processes. More volatile ices, methane, ammonia, probably once covered young Arrokoth. But with pathetically weak gravity and brutal cold, over billions of years these lighter volatiles evaporated into space. The near absence of surface water ice might mean it's hiding beneath organics, or perhaps the solar, Nebula region where Arrokoth formed was so frigid that water ice collected into larger bodies, leaving this planetesimal formed mostly from carbon-rich ices and dust. Regardless, its composition proves planet-building materials were diverse. Studying them up close reveals the chemical environment of the outer solar system 4.5 billion years ago, the same substances that likely reached Earth via comets and asteroids, possibly seeding life's building blocks. This lifeless body has preserved in deep freeze the organic chemistry of the sun's infancy, potentially a starter kit for the recipe of life. These discoveries inevitably raise the question, could life exist in Pluto's ocean? If Pluto maintained liquid water for billions of years, that means a stable, aqueous environment, the foundation of all life we know. The ocean likely contains ammonia and salts, acting as both antifreeze and potential nutrients. If there's a heat source providing thermal and chemical gradients, perhaps hydrothermal vents on the ocean floor like Earth's, that could power metabolism. Of course, there's no proof of life on Pluto. New Horizons carried no instruments for detecting biological signatures, but the mere existence of a subsurface sea in this distant, starved world suggests the planet might be far more habitable than anyone dreamed. According to researchers, beneath Pluto's frozen surface, any life would be shielded from cosmic radiation and insulated from temperature extremes. Such organisms would almost certainly be microbial and chemotrophic, extracting energy from chemical reactions in rocks and water. While improbable, the question remains open. Did microscopic life arise in this hidden ocean? Or might it exist there even now? We won't know until a future mission probes those deep, dark waters directly. New Horizons gave us only fragments, a few days of Pluto data, mere hours of Arrokoth observations. Yet even these fleeting glimpses fundamentally transformed our understanding. Years later, scientists are still mining the data and making new discoveries, but countless mysteries remain, with only tantalizing hints emerging. Has Pluto erupted recently? Is cryovolcanic activity happening right now? How exactly does the climate shift as the atmosphere collapses and regenerates? Does the subsurface ocean touch the rocky core, or is it sealed beneath hydrate layers? How thick is the ice shell? Could liquid pockets exist closer to the surface? Are all cold classical Kuiper Belt objects like Arrokoth, or is it unique? Answering these questions demands new missions and bold approaches. Enthusiasm is surging in the scientific community for returning to Pluto. NASA has already funded preliminary studies for an orbital mission, not just a flyby, but a probe that would enter orbit and study the planet and its moons for years. The concept envisions creating detailed high-resolution maps, tracking seasonal atmospheric changes, and possibly even landing a probe or impactor for close-up surface analysis. Meanwhile, New Horizons itself continues outward, measuring conditions in the Kuiper Belt and heliosphere, the bubble of space carved by solar wind. What Pluto and Arrokoth revealed is that the outer frontier isn't a frozen graveyard. It's a region of active geology, dynamic atmospheres, and ancient chemistry preserved like fossils in ice. As new missions take shape, we're not waiting for distant dreams. We're waiting for the next discovery that's already beginning to emerge from the darkness.